Yes, good evening, everyone. Am I audible? Good evening. Am I audible? Okay. Thank you, sir. Okay. So what we discussed in last lecture, can anyone tell me? Communication, right. So what we covered in communication? Transmitter. Okay. Sorry. So basically, we covered or we discussed about the uh, basic communication system, that what is communication and what is the steps that we use for communication, that is transmitter, channel and receiver, right? So this was a basic structure or diagram, block diagram of communication. Then we discuss about the frequencies, that we have various frequency bands, and what is those ranges and what are their application. Okay, so we covered all these things, and these comes under IEEE spectrum. Okay, IEEE is Institution of Electronic and Electrical Engineers, and this is actually responsible for defining the rules and regulations, right? And it is basically a institution that also provide the new topics, and we can publish our new research, okay, on various journals and so many conferences. Okay, so IEEE is responsible for defining the rules. Just a minute. Just so today we will discuss about the communication techniques. So first we should know what type of data we have. The information will be in two forms, that is in form of analog and digital. Okay. So these are the types of information that we can have. Okay. So for processing analog and digital, we have some communication techniques. So what is the basic process or technique that we use for transmitting the information for longer distance? Because as I told you yesterday that if the distance is very less, then we can communicate directly. Okay, we can directly communicate with any other person. So whatever I am saying, he is able to listen that. But the distance is increased, then the ability of listening that information or signal becomes weaker. Okay, so what we can do, we can use the process so that it can travel longer distance. Suppose it is 50 kilometers or 100 kilometers, then we cannot transmit the signal directly to that receiver side. Okay, so we will use the technique, the communication process. Okay, so what is that basic process? That is actually modulation. Okay, so what is modulation? We will discuss in coming slide. Okay. So modulation is actually the process that will be used for uh, sending the information on at longer distance. Okay. So before understanding the modulation, we should know what are the parameters of any signal. Okay. So I'm just drawing here. Okay. So what is that parameter? So we have three parameters: amplitude, frequency, frequency, and phase. So these are the three parameters of any signal, right? Whether it is analog or digital. So what is amplitude, what is frequency and phase? So frequency and phase actually shows the angle, okay? The angle of the signal, right? And amplitude is the height, height. So suppose we are drawing any signal like this, for example. So this is the height, this is the height of the signal, and it is showing the amplitude. And this is time. So frequency, or we can say angle, will be shown in terms of time. In terms of time, so it is actually the frequency we can show. Okay. So because we know the direct relationship between time and frequency, F is equal to 1 upon T. We have already studied in physics or science, right? So frequency is the reciprocal of time. So using this time, we can find the frequency. Okay. And similarly, the phase. Phase is basically the angle. So combinedly it comes under angle, because whenever we talk about the types of modulation, then we have two types, amplitude and angle modulation. Okay. Right. So depending upon the types of signal, the signal can be analog or can be digital. So what is analog? So analog is basically the signal which is continuous. Continuous means if any signal, it is not required that signal will be in this shape. The signal may be in this shape. This is signal. Okay, there is no certain shape of any signal. Okay, it depends upon the information that it contains. So this is continuous. So it is starting from this point and ending at this point, right? So it is continuous, and it is showing basically the analog signal. So whenever we draw it, we consider time at x-axis and amplitude. And amplitude is basically the voltage. What amplitude is showing? Amplitude is showing the voltage of the signal, of the given signal. So if you see the signal, suppose this is time t1. At t1, what is the value of the signal? This is the value of the signal. At t2, I don't know what is the gap between t1 and t2. I don't know. But after that, the value of this signal is this. Again, at this time, that is T3, the signal value is approx this. Okay. So you can see that at any random time, the value of the signal is not same. It may be same, but it is not required, right? So in these three cases that we considered, we have all three different values of amplitude or voltage, right? So this analog signal can have different amplitude at random time. Why I am saying random? Random means it is not required that the second signal will be at sec after 1 second it will be a second. It will be a third second. It will be a 4 second. So if I am considering 1, 2, 3, 4, so gap is 1 between all. 1 to 2, gap is 1. 2 to 3, gap is 1. 3 to 4, gap is 1. So gap is same, right? But in this case, I don't know what is the gap between T1 to T2 and T2 to T3. I don't know. So it is random, right? Without knowing the gap, we have considered the time like this or this. Okay. Clear? Any doubt to this point? What I am saying? Okay. So this is about the analog. And once we see the digital, so digital means it is actually binary. And binary means 0 or 1. The information will show either 0 or 1. It means there will be two levels only. Like in this case, there are n levels. This is this, 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 right? So at every time, the level is different. So we can say it is infinite or n number of levels. But in case of digital or binary, there will be two levels, either 0 or 1, right? So how do we show that? So 0 is at, suppose this is x-axis, this is time. So this will show 0 level and it will show level 1. Okay. So there may be continuous one. So this is time t1, this is time t2, this is t3 like this. Okay. So after that, continuous one will be this. So it is 1, it is 1, it is 0. And again, if it is 0, then we will write 0 like this. But we will connect like this. We will connect like this so that we can understand what is the signal actually. Suppose we draw like this. So will you understand? No. Once we connect it, so you can say that it is 0, it is 1, 1, it is 0. So depending upon the height. So you can see that continuously this is the signal 1, this is the signal 2, 3 and 4. So you can see that 2 and third, second and third both are same. So it will be at same level. There will not be difference between their height. Got it? So we have only two levels, either this or it's up to you that whatever the height do you want, you can. But it will be same for all months in the signal because signal may be 1 0 0 0 1 1 1 1 0 like this. Okay. Whatever the information is, accordingly we will draw it. So wherever we have 0, we will draw at x-axis like low level, and wherever we have 1, we will draw at high level. Okay. So 0 is showing low level and 1 is showing high level, right? Any doubt? Right. Now this signal, this diagram is showing the combined signal. This, the green is showing the analog and purple is showing its respective digital value, right? So how we can draw it? So you can see that from this point to this point, the signal is continuously in increasing mode. So wherever it is in increasing mode, it will show 1, right? If we are at this level, next is this, next is this, it means it is continuously increasing. Then we will show it by 1, continuously 1. Okay. So you can see we started from this point. So increasing, then we will increase it. Again increasing, increasing. Now the signal starts decreasing at this point. Okay. Then we decrease this. Again decreasing, further decrease. Again decreasing, further decrease. So up to this point, it was decreasing. And after this point, it is increasing. Again, it will be. So what will be the value? So it will be 1, 1, 1. Now at this point it is decreased 0. Again decrease 0. Again decrease 0. Again decrease 0. Then 1. Done. And if it is continuously increasing, it will be okay. So depending upon the increment or decrement, we can draw its respective digital signal in form of 0 and 1. So it is actually the staircase. It is known as staircase. Staircase means CD. Okay, we have stairs at our home. So what is the use of that? If you want to go upside, you step up. If you want to go downside, step down. So it is known as stair. It is R. It is staircase. Okay, and this is known as step size. Whenever you construct your home, then architect or engineer, civil engineer will ask you what step size do you want. Okay, if you have old person at your home, the step size will be low. It will be less because old person cannot means put the fit at higher level, right? So it is like 7 inches. You can take it 8 or 9 for younger, right? So it depends upon the age of the person or the family member. So this is known as step size. Clear? Any doubt? So have you understood how we can draw the digital signal of given analog signal? Yes. So these are the types of communication as we already discussed that depending upon the medium, right? Depending on the medium of sending the information. So it may be wire or it may be wireless, right? So wired means if we have physical medium to send the information, and wireless means if we are using the air medium. Okay, so air is being used for sending or propagation of the signal. Propagation means the traveling of the signal. So this is transmitter, this is receiver. So this is the medium through which the information will be sent and it will travel through that. Okay. So in wired, that is known as line communication. Line means cable, wire. Okay. So we have various type of wire or cable. So this is parallel wire. Parallel wire means if you remember the TV cable. TV cable means I am talking about the 20 or 25 years back. So there was cable like this. Two parallel lines were there. Okay. So this is one cable, one wire, this is second wire. Okay. And this was the plastic part. Okay. This was the plastic. So this cable is known as parallel wire communication. So what we are doing, we are receiving the TV signal through antenna and coming towards our television. Okay, so that was the parallel wire. Okay, so this is known as parallel wire communication. And second is twisted wire. Twisted means if you can see the wire having red and yellow, blue and black, right? So there are so many combinations. So you can see like this. So this is the twisted cable. Okay, so two wire are actually twisting each other. So that wire is known as twisted wire. So if we are using that wire means sending the information through that wire, then it is known as twisted wire communication. Okay. And coaxial cable means that is the dish wire. Okay. Dish that we are using nowadays. So in dish we are using coaxial cable. So there are two levels. One wire is inside that. Then this is the insulator. Above that there was this is the this is the wire that is actually for grounding, and this is the main line, right? Clear? And above that there is plastic cover that is known as shield. Okay, so this is the cable, this is known as coaxial cable that is used for dish purpose. And last one is optical fiber. Optical fiber, you know well, that whatever the connection we are getting at our home or in office, right? That internet is coming through optical fiber. And what is the advantage of using optical fiber is that the losses are very less, or least we can say. The losses are least in Means out of these three, four type of communication, that is why we prefer optical fiber. It costs higher, but the output is good, right? Output is good. Why output? Because losses are very less, and due to that, we are getting high speed internet. So speed is high. So information can be transmitted within very less time. So we prefer optical fiber. Got it about all these wired line communication? Now wireless. Wireless means the air medium we are using. Air medium. So ground wave means if earth is this, so this is one antenna, this is second antenna. So we are sending it, and height is very less. It is very, very less. So it is directly communicating with each other, right? And sky wave means this is the layer through which the signal will be reflected back to the transmitter side. Space wave, the above height. So it is transmitted in higher because we want to send at longer distance. And if because earth is like this, and if we want to transmit here, then it is not possible. So what do? We use the satellite. So the information will be sent to satellite, and it will send back to this receiver. So depending upon the distance, okay, at how much far the receiver is, depending upon that, we decide that type of communication. So the D2S that we are using, D2S means direct to home. So it is also known as DTH, right? D2S, DTH. So direct to home means earlier we were getting the dish connection through dish provider. Okay, there was agent. He comes to our home and we pay the money. Okay, so the signal will be received by him first at his home, then it will be sent through the cable at our. Okay, so that was through that person. Now we are just calling the Tata Sky and getting the connection at our home. So nobody is there between the company and us, right? So this is due to satellite. And why the antenna height is very less? Because this is satellite communication and the frequency is in gigahertz. Gigahertz is very high frequency. And due to high frequency, the height antenna is reduced. In older days, the antenna was 10 meter or 12 meter height, right? Now it is only this height. Okay, so this height is reduced due to this frequency, high frequency. So understood all about wired and wireless. Analog wavy graph, digital is shared. Yes, analog is wavy graph, like waves, right? So now the process that I was talking about, that is modulation. So modulation is what? Because first I want to ask you that what is the audio frequency range? What is the audio frequency range? Do you know what is audio frequency range? Audio frequency means the frequency that our ear can hear, right? We can hear. The frequency is known as, yes. Okay, so this is known as audio frequency. So what is the frequency range? That is 20 hertz to 20,000 kilohertz. 20,000 hertz, it is 20 kilohertz, right? So Sanjit, you are right. So it is 20 hertz to 20 kilohertz. Okay, so this is the frequency. The frequency less than this and higher than this cannot be heard by us. right? That is because we can listen this frequency range only. Okay, our ear are sensitive to what's this frequency range, not less or beyond that. Okay, so whenever the information we are talking about audio signal actually, right? In communication, what do we want? We want to send our audio signal. Okay, so that signal will be of this frequency, between this frequency range only. Okay, but this frequency is very low frequency. It cannot travel longer distance. Okay, it cannot cover longer distance. So what do we want? We want to send it. Suppose your relative is 100 kilometers away from you and you want to talk with him. Then how your information will be sent? Then we have to process it. And that process is actually the modulation. So what we do? Suppose you want to go 500 meters away from your home, then you can go on foot, right? But if it is 2 3 kilometers, then you will ask for bicycle or bike or scooty, right? So what is this? That is the carrier actually, because you cannot go on foot uh, at 2 kilometers or 3 kilometers. So you want one cycle at least, so that you can go on. Means you will put yourself on that bicycle and travel, and you will easily reach there. So you are using the carrier, right? And carrier is the high frequency because the signal is lower frequency. So we are using high frequency signal. Okay. So this is high frequency signal. So carrier is high frequency, and due to high frequency, it can travel longer distance. Okay. Like cycle or bike or car or or bus or train can travel longer distance. Similarly, high frequency signal can travel longer distance. That is why we are taking the help of that high frequency. Okay. So in modulation, what we are doing, we are putting, suppose this is cycle, okay, and you are putting yourself on it. So this is my drawing is not good, but trying to draw it. Okay. So this is, you can consider it as bike or car, bus, oh sorry, bicycle. So if you are putting here, so this is the information and this is the carrier. So you are putting yourself on cycle. So that process is known as superimposition, right? So what we are doing, we are superimposing the information that is known as message signal. And what is that? It is actually low frequency that I told you. And on which we are superimposing? We are superimposing on carrier wave, and carrier wave is high frequency. Carrier is of high frequency, and due to high frequency, it can travel long distance. So if you have put yourself on bicycle or scooty or car or bus, then you can travel 2, 3, 5, 50 or 100 kilometers. Okay. So depending upon the vehicle that you are using, you cannot travel 500 kilometers by cycle or bike. Okay. You need bus or car, train or car, whatever. Depending upon the distance the carrier is required. Okay. So modulation is nothing but the superimposition of the message signal that is of low frequency on the high frequency carrier wave. This is the basic definition of modulation. And after modulation, the signal that we will finally send is known as modulated if work is done. Okay. After transmission, it is known as transmitted, and after modulation, it is known as modulated wave. right? So the signal after modulation will be known as modulated signal, and finally we are transmitting it only. Clear? Understood or not? One more example I can give you. In childhood, what do we want? Suppose we want the neighbor, which is means in front of our home, there's your friend, okay, and you want to throw one paper. Okay, so what do? You just hold the paper, make it like a ball, and throw it. If the distance between your house and his or her house is less, then that paper ball can reach there. But if distance is longer, and because you were child at that time, so you can think that how with how much power you can throw it, right? So it cannot reach. So finally, what do? You just put one stone inside that paper and fold and make the ball. And after that, it can reach at that home very easily. So what we did, okay, we did in actually play, but it was actually a process. And that process is modulation because upon that stone, you folded the paper and made the ball. And due to that stone only, that paper could be thrown at that home of your neighbor. Clear? So this was actually modulation that you done in play, but you used one of the processes for communication. Yes, and stone is actually the carrier wave, and paper is actually you wanted to throw the paper. That was the required thing that you want to throw. So that paper is actually the information that is the message signal. And stone was the carrier because carrier that stone carried your paper at that home. Okay, so this is again the second example that you can think of. So this is the frequency range that we already discussed. So we want to send or transmit the low frequency range signal. It can be between 20 Hz to 20 kilohertz, and it is not possible to send this signal without any process. So this is the modulation process through which we can send it. And if we use modulation, the size of antenna is also reduced. Okay, the height of antenna is also reduced due to modulation, and effective power radiated by antenna also, because the frequency is high now. Then because what antenna does, antenna radiates. Okay, radiates means it sends the electrical signal in form of EM wave through air. Okay, so it can radiate very effectively in the air. So this is the second reason. And mixing up of signals from different transmitters. So as I told you earlier, that every signal is of different frequency. Suppose I am one transmitter, second is second transmitter, third is third transmitter. So every transmitter is allotted a particular frequency. Okay. So if we want to send all the signal through that medium only, or signal means single medium only, then we can mix it and it will not interact or interfere each other due to different frequencies. Different frequency means suppose you get the means reservation. What is reservation? Reservation means the seat is fixed for you. Nobody can sit up on that seat. So whenever you go there, your seat will be vacant. So similarly, every transmitter or channel has different frequency, and that frequency cannot be used by other. Okay, so mixing cannot be done. If we send all the signals at a time, then all the signals can be separate because they have different frequencies. like FM in FM. Okay, 98.5. So whenever you press 98.5, you will listen that channel only. Okay, if 95.0 any frequency, so it will have certain channel only. No, it doesn't mean that whenever you start today 95 and if you start tomorrow there will be different channel. It is not possible. Okay, same company will radiate or send the information at same frequency every time. Got it? So what I told you that there are parameters. So amplitude is one of the parameters of the signal. So what we are doing in modulation actually? So we are actually varying the parameter of carrier wave because information or message signal, whatever we have, okay, we cannot change anything. If we change any of the parameter like amplitude, frequency, or phase of message, the meaning will be changed. It means message can't be changed, can't change, right? So what we can do? So we are using the carrier. So carrier wave is there, and carrier wave has also the same parameter, amplitude, frequency, phase. So we can vary this parameter that is known as amplitude of carrier wave. Then the modulation process will be known as amplitude modulation. Message cannot be changed. We cannot change the parameter of message. If we change, then the meaning will be changed. So we cannot touch message. So what we can touch only carrier wave because carrier wave has no information. It is only the carrier. It is only carrying your information. Okay, so we can change the carrier. Okay, so carrier wave will be varied. Okay, it will be varied. Now, what we are varying only amplitude. So we can vary one of the parameter at the at a time, right? If we are varying amplitude, then frequency and phase will be constant. If we vary frequency, then amplitude and phase will be constant. Okay, so out of those three, one parameter can be changed at a time, and remaining two will be constant. So in amplitude modulation, what we are doing, we are varying the amplitude of carrier wave in accordance with the message signal. Depending upon or according to the message signal, we will vary the amplitude of carrier wave, and that process is known as amplitude modulation. Right? How we are varying, I will show in the diagram. You can see here. This is the way. This is the carrier. This is your message signal. This is your actual information, right? Message means information, and carrier is the high frequency. Now, how can you say that it is high frequency and it is low frequency? So this is high frequency, this is low frequency. So we can see this relation. If time is low, frequency will be high. If time is high, frequency will be low because it is reciprocal. So for this time, for this one cycle from this point to this point, only one cycle is completed, one, and within this time period only we have so many cycles, one cycle, two cycle, three, four, five, six, and so on. Okay, so if within that time period if we have more cycles, it is high frequency. Okay, and within that time period if cycle is less, then it is low frequency. Okay, so it is low frequency, it is high frequency. So this is carrier wave, this is your message. Now after superimposing means this signal will be superimposed on this carrier. You will be put yourself on cycle. So after that, what is being done there according to the signal? So you just see this directly. Okay. In this case, the amplitude is same, but here amplitude is lower, higher, lower, higher, like that. So at every time the amplitude is increasing or decreasing, through which it is being increased or decreased depending upon this. So you can see that from this point to this point, it is increasing. So you can see that up to this point, it is increasing, and from this point to this point, it is continuously decreasing. So you can see it is continuously decreasing. After that, it is increase, then decrease. Like, okay, so it will be increase or decrease in both directions, positive as well as negative. Okay, so this is the modulated after modulated. Okay, this message signal will be known as modulating. Why modulating? Because it is modulate doing the modulation process. And doing the modulation process means it is varying the amplitude of carrier wave. So this message signal is known as modulating signal, and after modulation it is known as modulated signal. Okay. So modulating is the message, modulated is the after modulation signal, right? So you can see that the carrier which was of constant amplitude is now with varying amplitude. Okay, you can see here amplitude of its carrier wave is varying. Okay, but amplitude of modulating signal is remain constant because we cannot change anything of modulating signal. What modulating signal? Modulating signal means message. So message will remain same as it is. Only the change will be in carrier wave, and that change will be done according to the modulating signal. Clear? So this is amplitude modulation process. So we have carrier wave, then modulating signal, that is your information, then superposition, that is superimposing, and finally we will have amplitude modulated signal. Okay, you can draw only one, two, or three. It is okay. Okay, there's no need to draw it. No need, because these three are required. Carrier should be there, modulating signal, and modulated signal. Three things. So where do we use? We can use for broadcast transmission in AM, because in television, air band radio like FM, and and single sideband, because there are two sidebands in AM, right? So two sideband means actual information is in sidebands. So both sideband has the same information. So we can suppress one. Okay. So one sideband will be transmitted. So it is actually saving the power. Okay. And efficiency will also be increased. Second is frequency. So same process is there. Everything is same. In this case, we will vary the frequency of the module of the carrier wave in accordance the with the modulating signal, that is the information. Okay, you can see here modulating frequency modulation, the technique of processing encoding information of particular in by varying carrier wave frequency in accordance with the frequency of modulating signal. Okay, so it is not exactly frequency, but it is accordance with the amplitude, basically, right? Because understanding through amplitude will be easier for you. Okay, and you can see the diagrams in this, you can easily understand it. This is your message signal, this is your carrier. Because it is high frequency, you can see that within this there are many waves. So this is higher frequency, this is only one cycle, so it is low frequency. So what we are doing now, the amplitude is remain constant. Okay, what is the amplitude? This amplitude, but the frequency is not constant. You can see this cycle time, this cycle time, this cycle time, every time is same, but after modulation it is not same. You can see this is higher, this is higher, this is lower, lower, more low, right? So why it is varying? It is varying according to this. So from this point to this point it is increasing. So you can see the frequency up to this point is high. From this point to this point it is continuously decreasing. So it is decreasing means the time is increased up to this. And from this point to this point it is increasing. So you can see it is continuously decreasing the gap. And decreasing gap means the time is decreased. And time is decreased, it means the frequency is high. If time is lower, frequency will be high. Okay. And again from this point to this point it is again the frequency is decreased because time is increasing. And again it is this, it will again increase the frequency. So you can see that amplitude is remain constant while the frequency of carrier wave is varied. Okay, the modulated signal. Clear? So in amplitude modulation, the amplitude was varied. In frequency modulation, the frequency is varied of what? Of carrier wave, not message signal. Because message signal cannot be changed. We cannot change any of the parameters, amplitude or frequency of message signal. We can change in carrier only. Okay, we can change anything in carrier wave only, right? After modulation, that signal will be known as amplitude modulated signal or frequency modulated signal. So these are the modulation processes. So frequency modulation is already known to you, that is in FM. Okay, and this is basically used for audio, and AM is used for video, that is in television. Okay, right? So combinedly, because we use for both for video and audio, so combinedly we can use. But in FM, whatever we listen, we use only frequency modulation process. Okay, you can see in broadcast over FM radios. So what we understood, we already discussed all about the frequencies. Okay, what are the frequency ranges? High frequency, low frequency, ultra high, extremely low, extremely high. Okay, so all these were the frequencies that we have used, and it is known as the spectrum. Spectrum means there's wide frequency range, and we have split it into smaller frequency ranges, and it is done by IEEE, so it is known as IEEE spectrum, right? So these are the some review questions that you can give after understanding all the topics. Thank you so much. So this is all about the communication and the communication techniques. Yes, any doubt? Yes, Meena. That will be my last class. I'll cover transducer, strain gauge, and load cell, right? Okay. That will also cover in that. Rectifiers was completed. Meenal, RC and LC. Hello. Because L and C was used, na? Inductor and capacitor. Is not possible. Okay, I'll see that. Because rectifier I think it was covered. Okay. So no doubt. So I think we have 10 minutes. We can start the next unit, that is transducer, right? We can utilize. Okay. I'm just sharing that PPT. Just a minute. So this is your last module in which we will discuss about the transducer, RTD, strain gauge, and load cells, right? So this is these are the guidelines. So in this session, we will cover what is transducer, its introduction, what are the parts, types. Thermocouple will also be covered in that. And lastly, there will be RTD, strain gauge, and load cell. So these are the outcomes. So what is transducer actually? Can anyone tell me? Have you ever heard this word, transducer? I will send. I have collected the PPT. I think one faculty has not sent. Once I get it, I will send all the people. Okay. I will send in zip file. Okay, separately of all the subjects. Okay, Prasanjit. Okay. So what is transducer? So transducer is actually a device which is used to convert one form of energy into another. Okay. So what is the example? Because if I give you example, you can understand easily. Suppose I am saying something. So how the information or signal you are receiving. Okay. So what we are doing, I am saying something, that is the sound energy. Okay. Whatever I am saying is in form of sound energy. and the signal which will be sent at longer distance should be in electrical form. So that sound energy should be converted into electrical energy first. So who is doing it? Who is converting that sound energy into electrical energy? So that is the transducer, and that transducer is nothing but the microphone, mic. Okay, the mic that we use is actually microphone. So microphone is transducer which is converting my sound energy into electrical. Okay, so here it is microphone. I am saying something, so it is receiving that energy and converting into electrical form and sent to the wire. And that wire can the signal which can travel through this wire should be in electrical form. So transducer is converting one form of energy. This is one of the examples. Okay. Suppose you are using electrical weighing machine. Okay. So what is being done there? Okay. We are putting the object on that. It is pressing that, and that pressure is measured, and through that meter we are seeing that it is 2 kilogram, 2.5 kilogram. Okay, so how it is showing that? Because the signal which was converted into another form which was sent to that machine or displaying device, and it is visible to us. Okay, so everything is being converting from one form to another. Okay, so transducers are actually those devices. So we can use temperature sensors, okay, pressure sensors, strain gauges, accelerometer, photoelectric sensors. So all sensors, what they are doing, they are sensing. Suppose temperature sensor is there. So what is that? That sensor is sensing the temperature at that place, and whatever the form you want, you can convert, right? So we are using various transducer for certain application or uses. Okay. So we have mechanical transducers like pressure sensor. Okay. After pressing something, so mechanical conversion is there. Okay. And strain gauge is also there. Okay. So how they are working? They are working by converting mechanical force. Force means if you are putting something, so there will be force on that. Or that force can be in form of displacement also. Okay, and that displacement is made converted into electrical signal. Okay, electrical transducer like thermocouple, photodiodes. Thermocouple, where do we use that? Where do we use thermocouple? In refrigerator, right? This is used there. Suppose temperature is higher, then it will sense it. It will sense and convert into electrical form, and accordingly the compressor starts or stops working. Okay, so compressor is controlled by electrical signal, and that electrical signal is decided by thermocouple. If temperature is maintained, then it will switch off the compressor. Once the temperature increases at certain level, okay, so who will sense it? This transducer, and accordingly that will start the compression. Okay, so depending upon the transducer, it will work. It will start or stop the working of the compressor. Similarly, photodiodes. Okay, photodiodes means the photo means the light. Okay, so depending upon the light means falling on that, depending upon that it will switch on or off, and if it is off, then the current will not pass through, right? The device which is connected with that, it will not work. Okay, if once it is started means switch on, then it will start the machine or whatever we are connecting with it. Okay, optical transducers like laser, displacement sensor. Okay, optical encoders. And how they are working? They are working by converting physical quantity into light signal. Okay, physical quantity, it may be pressure, anything. That quantity will be converted into light form. Okay, and it can be detected or measured by electronic circuit. So electronic circuit is connected with that. If it is providing or sending the light signal, then it will be detected by electronic circuit, and depending upon that, it will work. Whatever the system we have connected with it, it will work accordingly, right? So transducer are essential. So suppose I am saying something, it is converted into electrical form and sent to you, and you have received, but you want to listen my voice, na? So it is again should be converted into sound. So who is doing that? It is speaker. So this speaker is this. Okay. So if you are saying something, I am saying if you don't have a speaker, you cannot listen. Okay. So that electrical signal will again be converted into sound, and that is done by speaker. So a speaker is also transducer. Microphone is also transducer. Okay, so we can say that without transducer, right? So many systems are using actually transducer, and it is very essential and important component of any electronics, right? So you can see it is playing a crucial role in functioning of many electronics. Okay, weighing machine, electronic weighing machine. We are putting something, we are just seeing how much weight it has. Okay, so it is possible due to transducer. And everywhere, so many systems are using transducer nowadays. So this is the block diagram of transducer. So it is non-electrical quantity. There is sensing element, whatever. Then it gives the response accordingly, whatever it senses, and there will be transduction element, means the device which will finally convert into electrical form. So this is a basic block diagram of transducer, that what are the steps of transducing anything, right? So necessity, you have already understood that we want the exact magnitude of physical forces like temperature, pressure, forces, right? So how much temperature is there, what is the pressure at this moment, how can we know that? Okay, so it should be converted into that form that we can understand, that we can see. Okay, so it should be converted into proper form or in electrical signal, and that electrical signal can be given to display device, and that device will give the information that this is the temperature, this is the pressure, this is the weight, whatever. So what is the role of transducer? It is to convert physical force into electrical signal so that it can be easily handled or transmitted for measurement. Okay, so I already told you this thing. So these are the advantages, that we can transmit it, it can be measured easily. Okay, less friction error is there, it can be controlled easily. Amplification and attenuation of electrical signal are easy. Amplification means if you want to increase or the power or amplitude, then, or attenuation can be least. Attenuation means the losses, and measuring instrument for measuring electrical signal can work accurately for. So I think it is sufficient for today. We will continue in the next session. Uploaded. I have already told to the LMS manager, Meena, right? I'll get the update what they have done it. Okay. 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 So thank you so much. Happy learning. Thank you. Thank you.